The basic process of adding and subtracting is the same for all numbers, regardless of whether they are integers or fractions. Here's a picture of 4 plus 7. And here is a picture of 40 plus 70. The only difference between these two pictures is in the scaling. In the first picture, each step represented 1 unit, and in the second picture, each step represented 10 units. Instead of making the step sizes larger, we can also make them smaller. For example, here is a picture of 4/5 plus 7/5. And here's a picture of 4/9 plus 7/9. Although it is possible to reduce some of the fractions on the number line, it is not recommended that you do this. The reason is because it becomes much more difficult to follow calculations when the labels are not presented in a consistent manner. For example, consider the following two pictures. The first number line is much easier to follow than the second one. There's nothing wrong with reducing the fractions, but while you're working with them on the number line, it makes a lot of sense to leave them in their unreduced forms. Example, compute 2/5 plus 4/5 using a number line. First, we will draw the number line using a scale of fifths. And now the calculation proceeds exactly as before. Start from 0, move 2 1/5 steps to the right, and then 4 more 1/5 steps to the right. Two fifths plus 4/5 is 6/5. In this case, the final fraction does not reduce. But if it were possible to reduce it, you should reduce it. It is best to leave your final answer as an improper fraction instead of a mixed number. The reason is that algebra equations usually do not use mixed numbers, so you might as well get used to seeing improper fractions all the time. Example, compute 5/6 minus 9/6 using a number line. Before we actually draw and label the number line, we want to think about what's going on in this calculation. We are going to move 5 1/6 steps to the right, and then 9 1/6 steps to the left. 5 to the right, 9 to the left, we're going to end up to the left of 0, and so we need to make room for that on our number line picture. Start from 0, move 5 spaces to the right, and then 9 spaces to the left. (5/6) minus 9/6 is -4/6, and we can reduce that fraction. 2 goes into the numerator and the denominator. So the final answer is -2/3. Notice that we factored and reduced in one line of work now. You should have enough experience by this point that this will not cause confusion. The purpose of doing these calculations on the number line is simply to review how we use the number line to conceptualize the process. In the end, we will not want to draw out the number line for every problem, but merely use it as a conceptual tool to help us get the answer correct. Example, compute -8/7 plus 13/7. We're going to draw a quick sketch to ground our intuition. For this problem, we need to move 8 steps to the left and then 13 steps to the right. Since we've gone more to the right than to the left, our final answer will be positive. We also need to figure out how far past 0 we've gone, and we can see that we use 8 steps to get back to 0, which leaves us with 5 more to go. -8/7 plus 13/7 is equal to 5/7. The sketch of the number line is not necessary in the final answer. We've just done it to help draw out your intuition. Example, compute 4/5 minus -12/5. Take a moment and see if you can recall how to work with subtracting a negative. Subtraction can be written as addition of the opposite. So 4/5 minus -12/5 is equal to 4 fifths plus the opposite of negative 12 fifths, which is a positive 12 fifths. And then we do the calculation. 4 fifths plus 12 fifths is 16 fifths.